Hi everyone! Today I'm going to go over the last section of chapter 1, which is solve absolute value equations and inequalities. So here are some definitions. Absolute value, which is denoted by the two bars around the x, is the distance from 0, so it's always going to be positive. An extraneous solution is a solution that doesn't satisfy the original equation. So that just means when you plug in your answer for x, it doesn't work in the equation, and when you check, it's not correct. We'll do some examples of those. Here are the steps to solving absolute value equations. First, we want to isolate the absolute value. If the absolute value equation equals a negative number, then it's not going to have a solution because, like we said before, absolute value is the distance from 0, so it's always going to be positive, or it can equal 0. So you want to split it into two equations, solve for each equation, and then check. So here are some examples. So if we have absolute value of x plus 8 minus 6 equals 3. So our first step is to get the absolute value by itself. So that means we have to get rid of the 6. So in order to do that, we're going to add 6 to both sides. So we get absolute value of x plus 8 equals 9. So that means inside the absolute value, it can equal 9 or negative 9 because both those numbers are 9 units away from 0. So that means x plus 8 can equal 9 or x plus 8 can equal negative 9. And then we're going to solve for x. So we're going to subtract 8. And then we get x equals 1 or x equals negative 17. Then we'll have to check, because if one of them doesn't work, then that means we only have one answer instead of two. So for when x equals 1, we're going to plug in 1 into the original equation for x. So 1 plus 8 minus 6 equals 3. So 1 plus 8 is 9. Absolute value of 9 is 9. And 9 minus 6 equals 3. This works. So that means 1 is one of the answers. Now we have to check negative 17. So we're going to plug in negative 17 in for x. Negative 17 plus 8 is negative 9. And the absolute value of negative 9 is 9. So this one works as well. So that means the final answer would be both solutions here. It would be both x equals 1 and x equals negative 7. Both of those answers are correct. Okay, next we have 4 plus absolute value of 7x minus 5 equals 3. So our first step is to isolate the absolute value, so we have to subtract 4 on both sides. So we get absolute value of 7x minus 5 equals negative 1. So we have an absolute value equal a negative number. So since the absolute value is always going to be positive, this is no solution. And for those, you don't have to check because there's no answer that would work. Okay, so the next one we have 3 times the absolute value of 5 minus 3x minus 6 equals 18. So we have to first isolate the absolute value. So that means we have to add 6 to both sides. And then we get 3 times the absolute value of 5 minus 3x equals 24. And since there's a 3 in front of the absolute value, you have to divide everything by 3. So then we get absolute value of 5 minus 3x equals 8. So then here we're going to split this into two equations because the absolute value can equal 8 or negative 8. So 5 minus 3x equals 8, or 5 minus 3x equals negative 8. Then to solve, we're going to subtract 5. So we get negative 3x equals 3, and then divide by negative 3. So we get x equals negative 1. And then on the right hand side, we get negative 3x equals negative 13. Divide by negative 3, and we get x equals 13 over 3. And leave your answer as an improper fraction. So leave your answers like this. And then now we're going to check. So let's first check x equals negative 1. When we plug that in, we get 3 times the absolute value 5 minus 3 times negative 1 minus 6 equals 18. So we get 3 times the absolute value 5 plus 3, because negative 3 times negative 1 is positive 3, minus 6 equals 18. And then 5 plus 3 is 8. And the absolute value of 8 is positive 8, so 24 minus 6 equals 18, which is true. So that means that one works. Now we have to check 13 over 3. So x equals 13 over 3. So we get 3 times the absolute value of 5 minus 3 times 13 over 3 minus 6 equals 18. And negative 13 times 13 over 3 is negative 13 because the 3's will cancel out. 5 minus 13 is negative 8. And the absolute value of negative 8 is positive 8, and positive 8 times 3 is 24. So we get 24 minus 6 equals 18, which is true. So that means this is the answer. So now we have absolute value of 4x plus 24 equals 8x. So for this problem, the absolute value is already isolated. So that means the absolute value of 4x plus 24 can equal positive 8x or negative 8x. So those are the two equations we're going to solve for. So to solve, we want all the variables on one side. So I'm going to subtract 4x. And then I get 24 equals 4x. And to get x by itself, we're going to divide by 4. So we get x equals 3. Oops, sorry, x equals 6. Okay, and then on the right hand side, we get 24 equals negative 12x. And then to get x by itself, we have to divide by negative 12. So x equals negative 2. So now we have to check that both answers work. So here's the check. Let's start with x equals 6. So we have absolute value of 4 times 6 plus 24 equals 8 times 6. So we get 24 plus 24 equals 48. So 24 plus 24 is absolute value of 48. And this is true. So now for negative 2. We have absolute value of 4 times negative 2 plus 24 equals 8 times negative 2. So we get negative 8 plus 24 equals negative 16. Negative 8 plus 24 equals 16. And the absolute value of 16 does not equal a negative 16. So this one doesn't work. So that means the only answer is x equals 6. That's our only answer for this problem. Okay, so those are the absolute value equations, and then we're going to move on to the absolute value inequalities. So here are the steps for solving absolute value inequalities. You want to first isolate the absolute value. If you have absolute value is less than a negative number, then it's no solution because the absolute value will always be positive, so it'll never be less than a negative number. And if you have the absolute value is greater than a negative number, then it's going to be all real solutions because the absolute value is positive, so that's always going to be greater than a negative number. Next, you'll want to determine if it's an and or inequality. If you have a less than symbol, then it's an and. So a way I remember it is less than. And if you have a greater than or equal to symbol, then it's a or inequality. And a way I remember is great or. So next you'll want to create an and or inequality and solve. And make sure you flip the sign if you multiply or divide by a negative number. So that's always what you do whenever there's an inequality. And then graph just like you would a normal inequality. So if it's not equal to, it'll be an open circle. If it is, it'll be a closed circle. And if x is on the left and it's less than or equal to, you'll be shading to the left. If it's greater than or equal to, you'll be shading to the right. So let's do some examples. We have absolute value of x minus 2 is less than 8. So the absolute value is already isolated and it's a less than inequality, which means it's going to be an and inequality. And for and inequalities, we can write them as just one long inequality. So it has to be greater than negative 8, so I'm going to write negative 8 on the left. So it's going to be greater than negative 8 but less than 8. So I take whatever is inside the absolute value, bring it down to the middle, and it'll be greater than the negative of whatever number we have on the right, and it'll be less than whatever number we have on the right. So then next to solve, we're going to add 2 to all the sides. So we get negative 6 is less than x is less than 10. So now to graph, I'm going to draw a number line. Make sure to include the numbers negative 6 and positive 10. So I'm going to count by 2's. So that'll be negative 4. This is negative 2, 0, 2, 4, 6, 8, 10. So both of these are going to have open circles at negative 6 and at positive 10. And it's an and inequality, so we'll be shading in the middle. There you go. So there's the first example. This is a easy and basic one. So next we have absolute value of x minus 4 plus 5 is greater than 3. So we want to first isolate the absolute value, so we want to subtract 5 on both sides first. And then we get absolute value of x minus 4 is greater than negative 2. So this is going to be one of the special cases. We have an absolute value is greater than a negative number. So again, this will always be positive because it's an absolute value. So that means this is going to be all real numbers. That just means any number that you pick on the number line will work for the equation. So I'm just going to include some numbers down here. And the number line should be completely filled in if you shade it, or you would just draw a number another number line on top. Okay, let's do another one. So we have 4 times the absolute value of 6 minus 2x plus 8 is greater than or equal to 24. We want to first isolate the absolute value. So we have to subtract 8. And then we get 4 times the absolute value of 6 minus 2x is greater than or equal to 16. And then to isolate it, we have to divide everything by 4. So absolute value of 6 minus 2x is greater than or equal to 4. So since our symbol here is great or, that means we have an or inequality. So we have 6 minus 2x is greater than or equal to 4, or 6 minus 2x is less than or equal to negative 4. And then now we're going to solve. So to get x by itself, we have to subtract 6 on both sides. And then we get negative 2x is greater than or equal to negative 2. And then to get x by itself, we have to divide by negative 2. So since we're dividing by a negative, we have to flip the sign. So we get x is less than or equal to 1. And then on the right hand side, we get negative 2x is less than or equal to negative 10. Then we're going to divide by negative 2. And we get x is greater than or equal to 5. This is the or. So now on our number line, we have to include 1 and 5. And at 1, we're going to have a closed circle, and at 5, we're also going to have a closed circle. So I'm going to shape these in. And for x is less than or equal to 1, that means we're going to be shading to the left. And for x is greater than or equal to 5, we'll be shading to the right. Okay, we'll do 2 more examples. So we have 9 times the absolute value of 3x minus 2 plus 15 is less than 51. So we have to first isolate the absolute value, so we're going to subtract 15 on both sides. And then we get 9 times the absolute value of 3x minus 2 is less than 36. And then divide by 9. So absolute value of 3x minus 2 is less than 4. And since it's less than, it's going to be an and inequality. So negative 4 is less than 3x minus 2 is less than 4. Then to solve, we're going to add 2 on all the sides. So negative 2 is less than 3x is less than 6. And then divide everything by 3. So then we get x, negative 2/3 is less than x. Negative 2/3 is less than x is less than 2. Okay, and then for my number line, kind of ran out of space, but it's okay. Okay, so I have to include negative 1 since negative 2/3 is between negative 1 and 0. 0, 1, 2, 3, 4. So negative 2/3 is somewhere between 0 and negative 1, and it's closer to negative 1. And 2 is right here. And since they're both less than and not equal to, they're not going to be filled in. And then it would be any point in this area. Okay, we'll do one more example. So if we have negative absolute value of 3 over 4x plus 4 minus 5 is greater than or equal to negative 11. So the first step is to isolate the absolute value. And then we get negative 3 over 4x plus 4 is greater than or equal to negative 6. And then to get rid of the negative in the front, we have to multiply everything by a negative. So this is also going to switch the sign. It's going to be a less than or equal to instead of a greater than or equal to. So this is why it's so important to isolate the absolute value before you determine if it's an and or, because if you determine it at the very beginning, we have a greater, but this is not an or inequality. And you also can't say that this problem is all real numbers after you see this in the original problem, because that was what we saw before we isolated the absolute value. The very first step is to always isolate the absolute value. Okay, so since this is a less than, this is going to be an and inequality again. So we'll have negative 6 is less than or equal to 3 over 4x plus 4 is less than or equal to 6. And then we want to isolate x, so we have to subtract 4 on all the sides. So negative 10 is less than or equal to 3 over 4x is less than or equal to 2. Then to get rid of the 4 in the denominator, we can multiply everything by 4. So we get negative 40 is less than or equal to 3x is less than or equal to 8. And then to get x by itself, we have to divide by 3. So our final answer would be negative 40 over 3 is less than or equal to x is less than or equal to 8 over 3. And we can just estimate these numbers for our graph. So negative 40 is a little more than negative 13, and 8 over 3 is a little bit more than 2. So on my number line, since these numbers are pretty far apart, I'm going to count by threes and just kind of estimate where the numbers would go. So for negative 40 over 3, that's somewhere here. And 8 over 3 would be somewhere here. And then since they're equal to, that means we're going to fill in the circle. And then we're going to connect them. And that's our graph. Thank you so much for watching. I hope this video helped you with solving absolute value equations and inequality. I know this is kind of a long video, but I did include timestamps, so hopefully that makes it easier for you to find what you need. Leave a comment down below if you have any questions, and I'll see you next time. Bye!